So today we're going to start looking at a couple of these little portable computers. Going to do a teardown. The first one we're going to start with here is this PC-8300, manufactured by NEC, I believe, isn't it? Yeah, NEC. NEC. So it's a PC-8300. Little portable computer with a LCD screen, a relatively decent keyboard, etc. This is the one we'll focus on first, and then we'll come back later and take a look at this guy as well, if I can get him out of the soft case. And this is, of course, a TRS-80 Model 100 system, very similar. You know, if we compare and contrast between the two, of course I won't be able to get this all in frame here, but you can see that they're very similar. The LCD size appears to be very similar. The basic system layout, you know, the keyboard layout with the caps lock down here in the corner, graph. I mean, this is obviously an NEC unit as well, rebadged for Tandy. F1 through F8 here versus F1 through F5. You know, this is certainly, I think, a little later generation machine. Very similar on the back side if we take a look. We've got this little switch down in here for memory power on or off. Very similar here for memory power on and off. But anyhow, let's dive into the 8300 first and take a look at it. Like I said, we'll do a teardown and then we'll come back in a subsequent video and look at the Model 100. And go from there. Let me get this Model 100 back in its little soft case. Offer it some protection. So sadly, I don't have any AAA batteries floating around. This has got this little battery compartment on the back here. It's labeled battery cassette, which I first took to be a cassette interface, but it's actually a little cassette to hold the batteries. And this guy actually opens up. And takes 4 AA batteries inside. This is actually clean inside, which I like. There's no signs of leaking batteries in there. I wish I had some AA's to throw in there. And just this little interface card. There's a couple of lines here labeled RSET. It doesn't have the resistor installed, but I think this is just an adapter. Really. To put the batteries in, clips down in, the screws are missing, and the battery pack plugs in. Obviously. Let's go ahead and just start taking a look inside. There's a compartment here. I have no, well, there's an edge connector. You probably can't see it. There's an edge connector down in here, so there's something that could plug into here. Probably like extra RAM, would be my guess. Something like that. We'll get more details when we get a little deeper into there. We've got this larger compartment down here at the bottom. Back these screws out. That should lift up out of there, and it does. There's some nice, nice attention to detail here. These, well, maybe not. These screws feel like they're captive, and I really thought they were till that one fell out. I guess they're not, so ignore that statement. Although it is brass inserts, the screws turn into. There's a ROM here. It's labeled something basic, if I can read it. Oh, Microsoft. So copyright 1986, Microsoft Basic. 8649 looks like the date code. It's part number 831000-438. Can't really read it. N83A or N93A Basic. Say copyright 86 Microsoft. So pretty common in these devices to have some kind of ROM expansion. This is ROM 0 and 1. Some jumpers here, and of course some aluminized shielding here for RF, and I guess keep fingers from poking around down in there. So we've gotten this far. I'm assuming there's a DC jack on it. Yeah, DC 8.5 volt. I'm hoping, I guess the first thing we need to test here is will the end I have on this. It does mate. So it's looking for DC 8.5 volts. I'm going to go ahead and use DC 9 volts. That should be fine. This is just a little switcher. It's got a range of voltages on it. The tips are actually replaceable to get center positive, center negative. I've got this jumper for center to be positive, which is pretty typical. And we can see here on the marking, this is marked center negative and the outside center positive, so I do need to reverse the end on this guy. This is why these are really useful. So it says a CEN on there with an arrow pointing towards positive. So if I pull that out and reverse it, if I can get it to plug back in, we've now converted that to center negative. Center negative matches here. So these little universal adapters, I think this is a Velleman adapter I picked up someplace, are really useful. Where's the power switch? The power's off. I don't think being the half volt high is going to necessarily matter. Hopefully I'm not making a mistake. And we saw it come up there. So I'm not sure how we scroll around here. So we can already see we've got a keyboard issue here. This key isn't working, but the back arrow does. Let's go ahead and enter basic. Looks like F1 is load. Let's do a list and see if there's anything. Oh, that would be list the program files. Looks like there's probably not any files. And here we go. Once again, demonstration, I can't type. For X equals, ooh, little key bounce there. Key not working. 255, 10. Being Microsoft Basic, this should work. 15, next X. And that should eventually dump the character set, which it did. Can I actually edit here? Oh, it's kind of working. I'm going to get out here. Base 127. Let's go ahead. Oh, syntax error. I bet that's still going to 255. Nope. So we've dumped the character set there. Pretty standard, uppercase, lowercase. It looks pretty typical. 1, 2, 3, 4, 5, 6. It looks like there's 8 lines on the little screen. It's got to be 40 columns wide looking at it. You know, the contrast at this angle where I'm sitting here actually isn't bad. I got a bit of glare from the lights here. But there's got to be a contrast control here. There it is. No, it's got a good contrast set. So for the age of that LCD and being backlit, I'm actually pretty impressed. I don't know how it's showing up on camera. I guess I could attempt to take a look here, if it's showing up at all. So it looks like set there. The camera's picking it up. Of course, I can't see it at all. So sorry that you didn't see what I was doing there. It was a little basic program just to dump the character set, and I'm sure that's showing up now. So anyhow, with that done, let's power down and see what we've got inside. Find my favorite little screwdriver. got a little container over there to drop the various screws into and attempt not to lose them. That one's very tight. See if I can get this one to break loose here. Wow, that is really tight and started to strip. Nope. There, popped loose. Proper size screwdriver will save you from destroying the heads. There's that screw. You can feel it attempting to open up. You can see potentially a little, having trouble picking up tools. I can see potentially a little latch there, detent the plastic. Now we'll come back around to that. Okay, it just lifts up off. There's actually a cartridge slot over here on the side I didn't point out. It's kind of interesting. So let's see how easy it is to take apart. That's a, sure there's a release on that. Yep, it's just really tight, don't want to break it. That releases that cable. There is two little connectors over here for the keyboard. They are size different and of course color coded different. And this little ground connector right here, which is very tight. Get a screwdriver more appropriate to the screw. And we'll separate the two halves here. I am, as always, working on a static dissipative surface. Though I don't have a ground strap on, I'm in good contact. Actually, let me bare the arms here. So inside, we've of course got the LCD screen. They are HD 41102, so Hitachi drivers. Pretty standard. It's a very large panel. It's very nice. The keyboard down here, it's obviously a matrix style. It looks like it's scanned back on the computer. There's no chip on here or anything to do the scanning, and I'm assuming probably rows and columns or whatever coming out of the cables. We'll tear a little deeper into that in a minute. The base unit here, very typical construction for the era. It looks very nice. Let's release another ground connection over here. And that comes to this little cartridge port. There's multiple grounds coming off of this, and these are on little pin headers that just pull off. That's just folded up underneath. You know, pretty typical looking to me construction for the era. Let's go ahead and see if the little cover here will come off. If I can get that screw to back up out of there. And oh, there's two more screws. Lots of screws in this guy. As I thought, there's one sitting up here. That did release that. connector. So there's a little piezo speaker there in the blue disc. It was, of course, plugged on down there. There's this little edge connector here, little door. The spring assembly for the door is on this metal backing plate. So it's some kind of a cartridge connector. It's actually a set of pin connector, so it's not a card edge connector. It's a set of pins for ROM, memory, game. I have no idea. We'll set this stuff aside. Like a nice compact little build. That just won't slide out of there. It's a mix of surface mount, so it looks like surface mount RAM. Those are 150 nanosecond. Can't read the part number. Let's see if I can find the better glasses. That's not the better glasses. Anybody who watches routinely knows I have a lot of glasses floating around. CXK5884M-150. I have no idea what size RAMs those are. 3, 4, 5, 6, 7, and 8 is over here. So there's I'm assuming they're probably well, there's enough pins they might actually be a full byte per RAM. I don't know, but 1, 2, 3, 4, 5, 6, 7, and 8 floating out here. And hopefully you can see the traces in the bus. You know, those are all in parallel, so they definitely, there's the data address bus running along there. We've got our modem, our phone line interface. Pretty sure that's a phone line interface sitting there. It's nice that all these little covers are here and in place. Yep. Well, that might be Ethernet. It's wide enough to be Ethernet, although that would be surprising to me if it was Ethernet given the age of this. It's got to be telephone for a modem. I don't know what else it could be. We've got a little cover here over a DB9. It's labeled BCR on the cover. I'm assuming it's probably a serial port. We've got a little cover in here. It's nice that all these covers are still here and in place. Haven't been lost over the decades. And a DIN connector. Let's see what these are actually labeled. Oh, interesting. So, floppy disk drive, FDD, external floppy disk drive on that RJ connector there. Phone is just a little DIN connector. BCR, I don't know what BCR is. Don't know what CMT is. Printer. Yeah, serial below, printer above, so RS-232. Don't know what BCR is. I don't know what CMT is. Interesting. And sorry, I've got the text all upside down here, and of course the little reset switch. That's interesting. That's external floppy disk drive. It must be some kind of a serial interface, given how few pins there are there. Looking at this little board here, I can't tell if it's some kind of power management, perhaps. There's a phone connector, which implies there's a modem built in, and part of me wants to believe that's a modem, the modem card sitting there, although it's hard to say. We'll continue. Teardown looks like it's just one screw holding that in place. I think it's just the stiffness of these cables down here. Those don't appear to be locking. Appear to me to just be friction fit. I don't want to destroy them trying to pop one up loose. Yeah, they're just a friction fit. They're just probably have never been, so little wires. I need to be careful not to bend the little wires. No, that little, so that's definitely a power control board. There's the DC jack in. Of course, a filter cap. It's a Rubicon, very nice. 10 volt, 2200 microfarad. So my dropping 9 volts in got close to the voltage rating on this cap. So 8.5 would have been better. 15% under rather than 10% under the max rating. But again, it wasn't on all that long. So yeah, this is a little power management card, it looks like. Honestly, it's a lot of stuff for just a power supply, but I'm guessing there may, given the inductor here, a couple of inductors, this may be switching. This is a TC-74HC100, so it's just a TTL logic, a quad NAND gate sitting there. Nothing too fancy. Let's set that aside. The backup battery right here has started to leak. We will remove that while we have it open. So that's going to be the memory backup. I definitely want to get that off the board now that I see it. Let's break these screws loose. And back those out. That one was already loose. I'm guessing there'll be another one over here. And of course there is. Got one here. I've already hit. I don't think those two need to be loosened up. I think they have to do with that connector. These are again machine screws. I'm guessing there's brass inserts underneath them. Oh, I can see there is. The construction quality here is really nice. These are turning down into brass inserts. So it's just not self-tapping screw cutting threads into plastic. That's a very nice detail. Certainly aids in the quality of the device. Trying to be careful here not to have the screwdriver go skidding off across the board and creating damage. Let me get these all captured. You can see we're close. It looks like to me it's really going to be these two here still need to come out. And we will have the board freed. Did I already back that screw all the way out? I did. Okay. I know I dropped a screw through someplace. There it is. So we've released the board. It's quite interesting. This RF shielding wrap, as you can see, wraps all the way around the bottom of the board. I like the construction where it's actually captured by the screws. That's actually kind of elegant. I do like that. It's of course plastic coated to keep from shorting out on the board. I do like it. It's a nice attention to detail, and you can see that these are all brass inserts where screws go in. Again, really nice attention to detail. We've got foam starting to die inside up here that I will scrape that all out before I put it back together. That's gummy and nasty, as is the foam down there. It's all very sticky and gummy. We'll set that aside. We've got the main board out here. You know, the printer interface just flies there. It is permanently soldered in. We've got some RFI protection devices here to knock the RFI on that edge connector down. I don't know if that would be considered an option or was originally designed that way. But if we go ahead and look at this battery pack here, you can see all the green corrosion where the pack is starting to fail, and I'm just going to go ahead and just plain remove that, get that off the board. There's no reason for that to be there. And over time destroying the system. I'm hoping to be able to just heat up the solder. I may have too fine a tip on here. Oh, got the temperature on the tip way down. Let me bring it up to a good working temperature and actually swap in a tip that'll be useful. There is silk screen markings for plus and minus, and it is sized for different sizes of batteries. So hopefully I can just heat one side of this and just like that have the battery fall out. This one might take a little more heat just because it was on the ground plane. That dead leaking battery has been removed. We caught it very early before it destroyed something. Go ahead and check just to see how much life there might be left there. This battery's still sitting at 1.4 volts. And it's a 2.4 volt battery, 50 milliamp, so you know it's definitely seen better days. I'm going to set that aside to get hopefully an appropriate replacement. You know, 2.4 volt, 50 milliamp. Looking at the footprints, it's quite interesting because we've got the ground here, we've got a positive here, and those two positives connected together. It's just a double-sided board. It sure doesn't look like they're both connected together. Let's buzz those out. No, they're not. So even though there seems to be another hole here for a different battery, the two pluses here are not connected together. So I'll keep that in mind. I will order the same physical size battery. You know, the ROMs sockets that we looked at earlier on the back side of the board. That basic ROM wasn't down in very tight. The edge connector where that little power box plugged in to bring battery power in. This was the memory protect on and off. You know, it's a nice little board. It looks to me like it was definitely machine designed. You know, there's no way I think this was hand taped. Being the era of automation, to be able to do that, very expensive, you know, computers. You know, it's a nice looking little board. There is, God, do I want to call it a bodge wire or is it intentional? I think it's actually intentional. So there's this large green, heavy gauge green wire here that snakes around, and there's actually a solder pad there, and the wire's soldered to it, and that is obviously on a big ground pour up on the top side of the board. So I do believe there's a ground pour there. Maybe there isn't. No, there's a ground pour there, and it comes over here next to the trimmer cap and juts through here. I don't honestly know if that was a bodge that was added later on or if that was designed in and they just couldn't get a heavy trace all the way around. Nice little board, 4.9125 or 4.9152 megahertz crystal sitting there. I don't know the Oki part numbers offhand, but an 81C55 is a PIO. It's got 3 parallel I/O ports in it. An 80C85 is going to be the processor. So it's an 80C85 processor. The STB236 I don't remember offhand. It's an RCA device, obviously. It might be the UART. Thinking about it. I'm going to guess these were custom devices. I'm looking for a difference in the markings. KKD01, C01, and B01. So these are some kind of a chipset. I'm sure all the glue logic. These are probably DRAM, so the DRAM controller, I don't think the 8085 has built-in a DRAM refresh. So I'm guessing these implement DRAM refresh. It's got to be the glue logic. There's really nothing else on here to be glue logic. So controlling all the peripherals, interfacing to the connectors, etc. So that really is the heart of the system. Processor, parallel I/O for some of the stuff here. I'm guessing UART. I may be wrong, don't quote me on that. Connectors up to the keyboard matrix. Connectors out for power. DC power came in back here through this board and brought down through. That floppy interface is quite interesting with the relay sitting behind it. The relay was part of why I thought this was a telephone interface. But it's labeled floppy disk drive, FDD. I'm assuming that's floppy disk drive. You may be able to see that the board wasn't tinned, so there's bare copper showing here. So even though it is solder masked and silk screened, there was no tinning that I can see any place on it, which is interesting. I'm seeing little hints of copper here as well, although those are leads from the relay. That doesn't really count. Don't know that there's a whole lot more to say about this card. There's another inductor, transformer, something, a couple of them sitting here. Looks like it's deteriorating in there, but it's just some kind of a glue to hold it in place. Nice little unit. Let's set it aside. And going a little deeper here. You can see that the keyboard is on a metal frame. I don't want to push down too hard here because I'm pushing down through the keyboard itself. And those all didn't require a lot of torque to break loose. It feels like a machine screw again. And it is, so I'm sure that's turning down into again brass inserts. Really like the brass inserts. It's just a very nice touch. As I've already commented 2 or 3 times, just a nice indication of quality of design for potentially repair or maintenance. It's interesting, these board guides for the keyboard just float in here. The keyboard should lift up out of there. And that's exactly what I expected. So the little tactile domes here that would be underneath the function keys. And these look like they're actually real keyboard keys and not like tactile domes, although they may be tactile domes underneath. It's hard to say. I don't know if I can get a keycap off easy enough to not feel like I'm going to break something. Don't want to stress those too much. But we'll give it a shot. Yeah, it's full travel. Doesn't feel like a tactile. It doesn't snap like these do. You know, it's a nice little full travel key. So like for this guy here that's problematic, it would be difficult to open that up and repair it. It could be done. You've seen me do it before, opening up on that Model 1, actually tearing the key mechanisms down to get a set that actually worked on that Model 1 repair. Get a nice little card or board. It's an Alps. It took a second to go to read that. It's an Alps keyboard assembly. So that's a quality name. It's got a plunger on one side of the shift key over here, and the actual key switch is right here. And of course the little metal bar underneath, so it travels evenly. And if you ever see these little metal bars up underneath, you can see the silver there. That's the one I press on this side, the bar's pulled down and pulls the other side down so the key travels evenly. It's got one on the shift key over here, it's got one on the enter key. You know, it's a seemingly decent quality little keyboard. It's nice to see. Set that aside and we'll go again deeper, and of course brass inserts every place. Thank you, NEC. That's just a great attention to detail. Great attention to doing it right. You know, from that quick look we took earlier, the LCD seemed completely functional. I didn't see any rot coming in from the edges, as has been common on other LCD supplies or displays. I'm sure there's not going to be a whole lot to see here. But we'll go ahead and tear it down. I am intentionally keeping all the screws on this front case here together. They're all identical looking at them. That lifts up out of there as well. Oh, interesting. It's got these little copper clips on here. I wonder what they're meant to do. I think they're actually meant to touch the metal bar here on the LCD. It's exactly what I expected to see. That's a nice large LCD panel. It's nice and clean, as it should be. But nothing remarkable here. It's exactly what you'd expect to see. Drivers on the back. LCD panel on the front. You can see nothing remarkable there. So let me sit this down in there first. I think it's going to be easier to put the LCD back in last looking at this. So we will approach it that way. Set that screen aside. That basically sits there. It sits down in. This guy was here. Yeah, this is a better order to put it back together. And with these little clips, the LCD screen will push up against. Get that anchored in there. Oh, that didn't shift as far as I thought it did. know, this is pretty much exactly what I expected to find on the inside. Very typical construction for the era. The brass inserts for these screws is a really nice touch. It'll be interesting to see if the Tandy unit, which was potentially built to a price point, will have details like the brass inserts, or if it'll just be self-tappers. There was a second ground cable that came in over here to this point, so I'm not going to put that screw in. Let's go ahead and set the LCD panel back in place. Like so, and I can see it pushing up on those little copper connections, and I'm sure that's exactly how it's creating a continuous ground. Get you to start. Ground is brought in from the system chassis here across this bar, and metal on the front of the LCD gets grounded down through it. Nice little build. I'm impressed. I just see great attention to detail all over the place. Put a bit of torque on these. It's the wrong screwdriver, that's why that's not grabbing well. Being careful not to let the screwdriver slip and go skittering across the board and breaking traces or pins on the driver chips, etc. You can feel the tactile switches under there doing their thing. Nice. And of course, by videotaping the disassembly, I do have a guide to follow to put it back together, but I am going to go ahead and get all that dyeing foam out. Don't know that I need to record the rest of the assembly here. It's just going to be the exact opposite of what you watched. Anyhow, I hope you enjoyed this look into this little early portable computer. I think we determined it was mid-80s based on the ROM here on the back. Yeah, copyright 86. So it's mid-80s build. Neat little machine. Obviously made in Japan. Anyhow, I will wrap this video up here. And in a future video, we'll look at the little Tandy. We'll talk soon.